BIM dimensions are different to BIM maturity levels, which we looked at in Learning Outcome 1.3. They refer to the particular way in which particular kinds of data are linked to an information model. By adding additional dimensions of data, you can start to get a fuller understanding of your construction project, how it will be delivered, what it will cost, and how it should be maintained. Every time a specific type of information is specified into the model, a different dimension is set, and for this reason, various dimensions have been generated. If we look at the image here, we can see that 3D represents existing conditions models, 4D represents scheduling, 5D represents estimating, 6D sustainability, and 7D facility management applications. So let's have a look at this in a bit more detail in order to gain a deeper understanding of what these different dimensions mean. 3D BIM is a process of creating graphical and non-graphic information and sharing this information in a common data format. This represents your initial creation of your 3D model, which will have intelligent information within it. 4D BIM, an acronym for four-dimensional building information modeling, refers to the intelligent linking of individual 3D CAD components or assemblies with time or scheduling related information. The use of the term 4D is intended to refer to the fourth dimension, time. So i.e., it's 4D is 3D plus a time schedule. 5D BIM is an acronym for five-dimensional building information modeling. Refers to the intelligent linking of individual 3D CAD component or assemblies with time schedule constraints and then with cost-related information. 6D BIM helps perform energy consumption analysis. The utilization of 6D BIM technology can result in more complete and accurate energy estimates earlier in the design process. It also allows for measurement and verification during the building occupation and improved processes for gathering lessons learned in high-performance facilities. 7D BIM is an acronym for seven-dimension building information modeling. Refers to the intelligent linking of individual 3D CAD components or assemblies with all aspects of project lifecycle management information. 6D BIM and 7D BIM are interchangeable. So a good way to look upon this is that 3D BIM represents the design model, 4D represents as it progresses into the construction process, 5D is to do with costs and it's mostly associated with the quantity surveying profession, 6D represents energy analysis, and while 7D is representative of the use of the building or the facilities management occupation. So let's look at this in even further detail and explore the benefits of 3D, 4D, 5D, 6D, and 7D. What this lesson will focus on is 3D and 4D, while microsegment 2 will then explore the benefits of 5D, 6D, and 7D building information modeling. So, in order to understand the benefits of 3D, we need to look at what the difference of AutoCAD drawings, which are traditionally used in construction, compared to Revit or another 3D package, such as one offered by Graphisoft or Nemetschek. While BIM tools such as Revit are technically CAD programs, the term CAD is used more for drafting programs. In terms of building design, CAD is essentially using a drafting tool such as AutoCAD to create lines and arcs to represent a building design. So if we look at the images here, when you select a wall in CAD, you can see that it's actually just a line. Lines have been drawn in parallel to represent a wall. If you look in the properties palette, the only parameter available is the line style. However, when you select a BIM wall, you can see that there's an actual wall element. In the properties palette are several parameters that can be used to define the wall. So let's look at this in further detail by exploring what this wall would look like in an actual design pack. Let's look at this example in a real model. So if we zoom in here, we can click on different elements within the model. And let's say we focus on this wall here. We can see over here in the Properties tab a significant amount of information about this. We can see the offset, we can see the top constraint, as well as some information about the dimensions. Up in here, we can see what type of wall this is. We can see that it's a basic wall, SIP 202mm. If we click on Edit Type, we can see a little bit more information about this wall. Down in here, we can see the analytical properties. We can see that the heat transfer coefficient is this number, the thermal resistance is this number, and the mass is this number. Further down, we can see some more information. We can see that a description of this is structural insulation panel wall with kiln and dry timber panel rain screen. And we can see that this information in here can be edited. We can add in information in here about the manufacturer, the model, and the fire rating. If I go up here further and I click on Edit within the structure, we can see exactly what this is made of. So you can see that the finished layer is concrete, sand, and cement, and the next layer is the wood stud layer. The core boundary is made of structural timber insulate, and then we can see the thickness as well in here. And we can see that the finished layer is interior plaster, and we can see this over here. So if we change this wall, we could come up here and I could change that to timberclad, and this will change to this here, and we click Edit Type. We can see that this there affects the properties as well as the makeup of the actual wall itself. With an understanding now gained of the difference between 2D and 3D, we can now look at other design packages available which will fall within the 3D design bracket and help to provide a greater insight into our final design. We previously looked at and learned Outcome 1.3, a software package titled Autodesk Format. This allows anyone to sketch, collaborate, analyse, and find early stage design. Another package is called Autodesk Insight. This package takes a conceptual design and runs analysis in order to optimize your designs earlier. It has provided an understanding of the performance from day one with energy and solar analysis, and one can see the relationship between design concept and site location with shadow and sun path. So to recap, numerous packages can be integrated together in order to find an optimum design solution. If format was used to provide a conceptual design, this can be integrated into Insight to provide an understanding of the analysis, and this can help with the client in the selection of the most sustainable and economically friendly option. Once it's selected, this can be brought further into the design package Revit, which we looked at in the previous tutorial video, and elements can begin to be added and the model can be begin to fleshed out and used within the design team. Further video is provided on this package through the link provided below. This is a guided self-learning requirement, and it is advised that you view this video in order to gain a further insight into how this package works, as well as a deeper understanding into how all of these packages can be integrated together to work within a seamless information flow. It is also important to note that there are a number of other software vendor providers that provide similar solutions, but we've chosen to use Autodesk in this example. Some of the software providers within the 3D space will be looked at the end of this part of the tutorial. A question that gets regularly asked is if BIM is only for new buildings. Well, BIM is not just confined to new buildings, but can also be used for existing structures as well. Advanced surveying equipment such as 3D scanners can take a point cloud of a building. A point cloud is a set of data points in space. The 3D scanner measures a large number of points on the external surfaces of objects around them. Tools such as Recap can create 3D models from imported photographs and laser scans, and then output a mesh ready for CAD and BIM authoring tools. Deploying cloud can be used to model existing conditions to assist with creating the initial design. Once the 3D design is complete or a draft has been progressed, there are a number of softwares that can convert the model into different virtual or augmented reality platforms. The example shown here is Google Cardboard, which can be used for virtual reality to immerse your clients within their design. More expensive options include Microsoft HoloLens, which combines an untethered device with apps and solutions to help people across their business learn, communicate, and collaborate more effectively. The self-guided learning link here provides instructions of how to use Graphisource BIMX, which is a free model viewer that incorporates IFC files, which IFC will be explained in further training units, and how this can be used in partnership with Google Cardboard. As discussed in Learning Outcome 1.3, BIM can be used by multiple design team members. Examples here are models generated for civils, structural, mechanical and electrical purposes. The model will have intelligent information within them that can be shared with other design team members in order to inform their parts of the design. These models can be used then to progress the 4D design, which we'll look at next. Here are an example of some of the leading 3D BIM softwares. There are a number of softwares available, with a number of available vendors offering student license within each package. So to recap, the 3D design can enable easily shareable designs that can help to communicate design with all the team members, including the client. Compare design options by generating multiple models that can also be used to generate important analysis. Facilitate improvements in the information flow by communicating the intended design changes. Access to data and information through a common data environment, as well as better team collaboration. With an understanding of the benefits that can be gained from 3D design, let's take now a look at 4D. 4D initially will involve the federation of a number of models. As explained in Learning Outcome 1.3, a federated model is a combined building information model that has been compiled by amalgamating several different models into one, by importing one model into another. Let's take a look at this within the design review package and see what's involved in regards to model federation. Here within the Navisworks Manage, we have a single architectural model, as we can see here. We can expand it and we can see all the floors within this model. However, the power of this package enables us to federate different discipline models. So what we're going to do now is going to show instance where we can federate the mechanical, electrical model along with the structural model. So what I'm going to do is I'm going to append these into the current file. And here we can see now we have our MEP model and our structural model overlaid or appended to our architecture model. You can hide it or unhide it. We hide the architecture model. We can see our two new models, the MEP model and the structural model. Once we have a federated model, one of the key things that can be formed is clash detection or clash avoidance. A clash occurs when components that make up a build asset are not spatially coordinated and conflict. In a BIM process, these clashes can be spotted more easily during the design phase of a project ahead of work starting on site. Let's now return to the design review package and look at this in further detail. If we look at clash detection, we are in Autodesk Navisworks Manage 2019 within the Clash Detective, and I've set up a clash for the MEP model to run against the structure model on the first floor. And we can see that it's found 85 clashes, and we can see down in here the list of clashes. So if I click on clash 4, let's say, we can see that the interior partition in the MEP is clashing here with the structural column. If we look at clash 41, for example, we can see that the fourth floor commercial 1 foot by 6 inch, this here, is clashing with, once again, the structural column here. And we can see that's clashing by minus 133 millimeters. These tools are very powerful, and you have the ability to clash anything that you want within the model and very quickly show the user potential conflicts that may happen out in site. So through the use of tools such as the clash detective, one is able to eliminate a potential number of clashes. And how to set this up and use this is explained in more detail in the digital skills module. The federated model can also be used to perform constructability reviews. Walkthroughs of the model can be formed to enable potential construction issues to be diagnosed. Let's return to the design review package again and see what this would look like within this software package. So looking at some of the review tools, we could enter the building, and let's say we have an issue with the door here. We could go to a review, we could highlight the problem, and then what we could do is we could tag it, and then we can add some information in here. And then this will be available for future users when they log onto the software. They could come along in here, and then they would come along and they could put on a review tool, a few comments, and then they can scroll through the potential issues that are highlighted here. The federated model can be used to understand potential site logistics, such as the best place to set up the site compound, access routes of least impact, material storage, or to highlight potential red flag areas. The federated model can also be used to help with visualizing site constraints. The model can be used to demonstrate what-if scenarios, which will reduce the impact in surrounding areas by understanding constraints that are associated to that environment. The federated model can also be used to provide 4D simulations. These simulations provide a more intuitive interface for contractors to help test the accuracy for build sequencing and evaluate interdependencies. Let's look at this in greater detail back in the design review package. Here we can see a video of the timeliner in application, and we can see where the crane is in position as well as the pylon rig. What this timeliner enables us to do is to look into the future of the project, and we're able to see potential issues or concerns or project lags or potential problems that might arise. We can see that we can plan best access routes, where to store materials, and we can virtually set up the site and imagine how that's going to look at the end of the project or all the way through the project through a simple configuration of the schedule to the model. The timeline can be used for location-based planning, as well as to understand issues that may occur within the critical path. The federated model can also be used for health and safety purposes. This can be achieved through model-driven prefabrication and off-site fabrication. The opportunity to do more prefabrication of materials off-site in a safe and controlled environment will help reduce possible health and safety issues. Scenario planning, so the contractor is able to explore a number of what-if scenarios and see which one could be potentially dangerous. Clash detection, as we already looked at, is the ability to identify collisions and mitigate these before they are constructed. So by avoiding clashes, can potentially avoid issues that may result in health and safety concerns. Model can also be used for visual communication, so the ability to communicate information visually can break down any language barriers and aid a deeper understanding. A further link has been provided here to help with guided self-learning. This link goes into further detail and recaps a number of the key areas discussed throughout this lesson. Here are examples of some of the leading 4D BIM softwares available within the market and the vendors that offer these solutions. Once again, a number of these packages are available as an educational license. So just to recap, the 4D building information offers opportunities for better materials management. This in turn will help with waste reduction, can help visualize health and safety concerns. It can be used for clash avoidance, for advanced scheduling opportunities through 4D simulations, and can help in bringing the whole team together through federated team collaborations and workshops discussing clashes found and opportunities to enhance the scheduling opportunities.